All right, I do not have a printout of today's notes with me, so you'll see the note paper here to the left, and then to the right, I'm just going to write this information on notebook paper. Okay, so first thing we're going to talk about is exponential functions, and the general form, the little thing I would put right in the blank there, would be y equals ab to the x. All right, and there's a couple rules here. A cannot be equal to 0. If that was 0, then that would wipe out the whole equation. It wouldn't exist. B has to be greater than 0, which means B has to be positive. Otherwise, you don't have an exponential. And the other thing is B can't be equal to 1. So if B was equal to 1, I'll show you over here real quick. So if I do 1 to the x, totally doesn't matter what x is. 1 to any power is just going to be 1. So that term would literally just cancel out, and it would just be a, which would be the equation of a line. So that's not going to do anything for us. So the b value is not allowed to be negative, and it's not allowed to be 1. Okay, now when you're working with these, we're going to do a couple different things today. But no matter what we do, b is what we call your growth or decay factor, and so that's what's going on with these two little things underneath here. So if you have exponential growth that says 1 plus r, r is going to represent a rate, and we'll get into that a little bit more with word problems. And decay is 1 minus the rate. That is what that value is. When you're looking at this question, x is going to be time for a general exponential, and a is going to be an initial amount. And those terms apply a little bit more to working with word problems, and we're going to start out with just some basic algebra here. All right, now, what I have in example 1, so let's just move this out of the way. So example 1 says, without graphing, determine whether the function represents growth, decay, or neither. Then state the percentage of growth or decay if applicable. Okay, so growth happens if the b value is anything bigger than 1. Decay happens anytime, since it can't be negative, the b value is between 0 and 1. Can't be equal to 0, can't be equal to 1. So between there, like a 1/2 or something like that. And then neither is going to happen if a is negative. If you have growth or decay, a has to be positive. So exponential growth, exponential decay. The a value will be positive. Growth, the b value will be bigger than 1. Decay, it'll be between 0 and 1. And then the question says growth, decay, or neither. You're automatically neither if a is negative. Okay, so for my example 1, we're not going to run into that because all the a values there look like they're positive. And I'm just going to write these real quick. Y equals 16 times 1/2 to x, and the last one is y equals 4 times 1.3 to the x. Like that, hopefully we can see them. Okay, state the percentage of growth or decay. So a value positive, all three of these, so check, check, check. Now, if you are less than 1, but bigger than 0, this is going to indicate decay. This 0.5 is going to be decay, and this bigger than 1 is going to be growth. Now, what's the percentage? There's a couple ways you can figure this out. If you have decay, you know the b value has to be 1 minus the rate. So you know the b value, and you can sit there and solve that little equation for the rate. And to do that, I would subtract 1 from both sides, and I would get negative 0.22 is negative the rate, and so those two negatives would be canceled out. That's your rate. To convert your rate to a percentage, all we're going to do is multiply by 100. So this is going to be 22% decay. Now, another way you can do that, just kind of figure out what would that be to add up to 1, and that'll be what you're taking off. So if that makes sense, like if I had 100% on a test, this would be 1. So if I have a 78, that means I had 22% taken off. So you don't have to go through that process of solving an equation. You can just kind of figure it out. It just needs to add up to 1. Whatever would make that add up to 1, that's going to be your rate. So like right here, if this is 0.5, this is decay here, to add up to 1, I'd need another 0.5 or 50%. That would be decay. Now, growth is a little bit nicer, but you can do, if you like the equation I did at the beginning, if you have growth, it's 1 plus the rate. So if you wanted to solve this, you know the b value here is 1.3. If I subtract 1 there from both sides, I get 0.3 is equal to the rate. Take and multiply that by 100 to get the percentage. That's a 30% growth. And then the other way, again, you don't have to go through that process. You can look at this, whatever it is over 1, so this is 0.3 over the 1, just multiply that by 100 and that'll give you your growth factor. So for that one, it's going to be, or just your growth, not the growth factor, sorry, the 30% growth. All right, the next thing we want you guys to be able to do is, if I give you 2 points, could you write me an exponential model that would go through those 2 points? So that's what's going on here. I just copied the 2 points that were on the paper. Now, here's the process. The general form is that y equals ab to the x, and we're going to use that here. What I don't know is a or b. What I do have are 2 given points, and I know that I have x and y coordinates there. So this is what we're going to do. We're going to set up a system of equations, and we're going to solve for a and b. What I would always recommend, start with the point that has the larger x value. So that's going to be the 2, 5 here. What I'm going to do, I'm going to plug this point into this y equals ab to the x. So I'm going to write 5 equals ab squared, because I know that y is 5 when x is 2. And then I'm literally going to repeat that, put that in for x and y. We're going to solve for a and b. So y is 3 when b is 1. Okay, so I have 2 equations, 2 unknowns, perfect. This is a little different than solving a system of linear equations. What we're going to do here, and this is totally legal, I am going to take and I'm going to divide the bottom line from the top line. Now, the reason I'm doing that, every time you set this up, you will always end up with this situation where you have a over a, which will always cancel out and become 1. So that's going to be the easiest way I can tell you to do this. Now, sometimes you might be able to divide, sometimes not. It's going to depend on the question. Here, 5 over 3, I'm just going to leave as 5 over 3. Now, I'm going to write this out on this problem. When we divide here, b squared divided by b to the first. You can simplify with exponent properties. Where do I have more b's, the top or the bottom? And you'd say one more on the top. What I want to remind you, when you divide like bases, you are not dividing exponents, you are subtracting exponents. So that'll probably come into play a little bit more in our next problem, but just keep that in mind. So I am not doing 2 divided by 1, I'm doing 2 minus 1, which would give me b to the first. Perfect. Here, I now have b. What we then need to do is figure out what a is. So it's just like substitution or elimination. We got to plug it back into either one of those original equations that we had. I usually like to use the one that has the lower positive exponent. So I'm going to plug it into that 3 equals ab to the first. Now, if I do that, set that up, 5/3 to the first power is just going to be 5/3. Now, to get rid of this then, what I would do is I'm going to multiply both sides by the reciprocal. That's going to become 1. That's going to be your A value. And then this is not the nicest of numbers, but I can just go ahead. I don't need a common denominator to multiply fractions. That's going to be 9/5. Now, what I want to look for is the actual answer, which is this format, exponential model that goes through both of those. A would be 9/5, B would be 5/3, and then to the x. And you guys can plug both of those points back in if you'd like to check. If you want to plug in the 1 for the x, that should simplify to be 3. If you want to plug in 2 for the x, that should simplify to be 5. And I'm just going to repeat that with one that has an example with negative exponents. So again, you know 2 points. You don't know A and B. That's what you want to try to figure out. Start with the point that has the larger x value. So 2 is bigger than -2. I promise it'll make it easier to do. So I'm going to set up 20 equals AB squared, and then 5/4 equals AB to the -2. Okay, we're going to divide the bottom line from the top line. That gets rid of or eliminates that variable A. Now, this is a teeny bit tricky, so I'm going to come steal some of the space up here. So I'm going to do keep, change, flip. I'm going to keep the 20. I'm dividing that by 5/4. They call it keep, change, flip because you keep this the same. I'm going to change this to be multiplication, and then I'm going to flip, keep, change, flip. The reason for that, if you divide by a fraction, it's the same as multiplying by the reciprocal. So this is going to go ahead and give me 80 over 5. Which, if I actually divide that, and of course you guys could use your calculator too if you wanted to, this is just going to be 16. Now, remember with those lovely exponents, b squared divided by b to the -2, it'd be minus a -2, which will turn into a plus. This will become b to the 4th. Now, to cancel this out, I'm going to take a 4th root. And normally, if we take an even root, we got to put a plus minus, but no, because if you're doing an exponential model, your b value has to be positive, so no plus and minus symbol here. This is just simply going to be 2 as your b value. Once you have that, you got to plug it back into one of these two equations. I would not want to mess around with the negative exponent, so I would probably plug it into that first equation. I would do 20 equals a, my b value is 2, so I can plug that in, 2 squared. 20 equals a times that would be 4. Ultimately trying to get a alone there, so I'd divide by 4. And a is going to be 5. Now my actual answer to the question, I know that's a lot of work there, but my actual answer has to be y equals a times b to the x. So for this problem, it'd be y equals 5 times 2 to the x. All right, and if you guys scroll down the page here, you'll see kind of the same question, but instead of me giving you guys points, you're going to have a graph. So the only difference is you just grab the points off the graph, and you only need 2 of them. Now, be smart about what the points are that you pick. If you ever have a point that involves a 0, which you definitely do here, use that. It'll make it super easy. So I'm going to use the point 0, 1. I'm looking at this graph. And then don't make it difficult. Don't use the ones with the fractions. Use the nice numbers. We're going to use the -1 and the 4. And then this turns into the same process. So that y equals a b to the x. I'll just write that in the middle of my paper so you guys can see it. It is on the screen here too. Okay, start with the bigger x value, whatever that is. So that's going to be this one. So I'm going to do 1 equals ab to the 0. And then I'm going to do the other point, which is 4 equals ab to the -1. Now, honestly, there's a couple different ways you could do this, but if you guys remember, anything to the 0 power is 1. So that b to the 0 power would just turn into a 1. So I actually already know the a value for this problem. And then all we have to do is plug that back in. I'm sorry, we know the a value. I have to plug that back in though so I can get the b value. So I don't have to do a system like I did on the last one, but I do need to plug this in. Okay, so I'm going to plug that into the other equation. So then we'll have 4 equals 1 times b to the negative 1. We'll have to solve this for b. All right, so 1 times b to the negative 1 is just going to be right here, 4 equals b to the negative 1. Now, remember, b to the negative 1 is the same thing as 1 over b. Okay, now this is equal to 4. I'm just going to turn it actually into a quick proportion to solve that real quick. So I would have 4b equals 1. So that means my b value is actually going to be 1/4. So then my equation, y equals 1 times 1/4 to the x, the ab to the x format. Now, honestly, you don't need to write the 1 in front. If you just want to write y equals 1/4 to the x, that will work as well. Okay, then I'm going to have you guys just ignore that other graph to save a little time, and I'm going to go ahead and move on to page 2. All right, the rest of the examples today are going to be word problems, but we're still going to use the y equals ab to the x. Okay, so let's do example 3, part A. All right, so it says the population of a city is 180,000 people. That is going to be my initial amount, so that's going to be the A value in that formula, and it's decreasing at a rate of 5% every year. So decreasing means we are going to have decay. So 1 minus the rate. In this problem, that rate is 5%. You have to change that to a decimal. So 5%, if you're not sure how to do that, just take your percentage and divide it by 100. And this is going to hold 95% of its population. So it's going to be 0.95 when we do this. Find the growth or decay factor. So that's going to be, this is going to be decay factor. That's going to be the 0.95. And write a model. So y equals 180,000 times 0.95 to the x. X represents time here. And then what is the population of the city after 6 years? So this is your model. And then we're actually going to use the model. So how many people, 0.95 after 6 years. We're going to put that in as 6. Do not multiply these two numbers together. That's the most common mistake people make. So we're going to do 180,000, and I'm just literally going to type it in right like that. And since we're talking about people, we got to think reasonably. Let's go ahead and round it to the nearest person. So I'm going to say after 6 years, we're going to have about 132,317 people. Part B, house was purchased for $155,000. That's going to be, my A value. And appreciating means increasing in value. So we're going to have growth here. 1 plus the rate. Usually that's true of real estate. 3.5% would be 0.035. So our growth factor here is going to be 1.035. So the 1 accounts for what you've already paid for the house, and then the 0.035 adds that right on for you within the question. So this is growth. So our general model here, the worth of the house would be y. 155,000 times 1.035 to the x, when x would represent time. And then it says, what is the house going to be worth in 10 years? So all we have to do is plug in 10 as our exponent there. So 155, let's type that right, 155,000, and then 1.035 to the 10th. Now, this is talking about the, let's slide that so we can read it, the value of your house. So we're going to round this to the nearest hundredth because we're talking about money. So $218,642, and we'll round that up to 81 cents. So good value for your home. One more problem here, and then we're going to do a special case, which is a half-life. Okay, an investment is worth $56,000 $578 after 8 years. The growth factor for the investment is 1.15. Find the original value invested, and then what is the percentage increase the investment earns every year. So here, your y equals AB to the x. You actually know what it's worth. $56,578. You don't know the initial amount, so that A value is what we're going to figure out. Now, the tricky part here, there's no percentage listed. They straight up say the growth factor. So the B value is the growth or decay factor. So we don't have to add one or subtract one. We're just going to plug that right in. The other thing that's a little different on this one, it says after 8 years. So we actually know the time as well. So this is going to be to the 8th power here. Okay, find the original value invested. So here's all we need to do. We need to, since we're multiplying this by A, divide both sides by that 1.15 to the 8th power. And I would just do it right like that in my calculator. So I'm going to do 56,578 divided by, and I'm just going to put this in parentheses, and obviously you can't see it because I'm not on the screen, sorry. I'm going to divide that by 1.15 to the 8th. That way we're not rounding this multiple times or anything like that. And so that initial investment, and we'll put 4 or 5 to the nearest hundredth since we're talking about money. So $18,495.45. And the last thing we're going to talk about here is half-life, which is kind of a special case of a general exponential. So the half-life, radioactive substance, is usually what this is for, but it can be other things. But just in general, a half-life of any substance is the time it takes for half the substance to decay. So you see a little box here for my half-life formula. Half-life formula is going to be y equals A. Now, because you're taking half the substance, the B value for a half-life problem is always a half. So it's 0.5, it's 50% decay. The other thing that's a little different is the exponent, and the exponent is going to be x over the half-life. So it's going to be a fraction, okay? X is time, and it has to be the same as the half-life. So, for example, if your half-life is in hours, then your X value has to be in hours. If your half-life is in minutes, then your X value has to be in minutes. So we're going to talk about that in one of the examples here as we go through. Okay, so we're moving on to example 4. And see if this makes sense. Okay, so first part just says we have, and a lot of times these are elements that have very bizarre names, but it says a hospital prepares a 50 milligram supply of technetium-99, which has a half-life of 6 hours. Write a formula to represent the decay of the technetium-99. So this is just going to be y equals, we have a 50 milligram sample, so that goes in for A. 0.5 is always for a half-life problem because we're doing half the substance's time to decay. And then it's x over the half-life. Back in the problem here it says the half-life is 6 hours. So I have to make sure when I do the problem that my x value is in hours, which is not going to be an issue here. Okay, now see if this makes sense to you. It says how much of the substance will remain after 12 hours. Now, if you're like, what is going on with that fraction? I think this will maybe hopefully explain this. So how many times, think about this for yourself, how many times, if your half-life is 6 hours, would you cut the substance in half if it was sitting out for 12 hours? Okay, so think about that for a second. And I'm just going to write it into the formula. It'd be 12 divided by 6. This is going to get cut in half twice. So if I'm going every 6 hours, I make it to 12 hours, it's going to get cut in half twice. So you'll notice my exponent, 12 divided by 6, it gets cut in half twice. I'm doing that 0.5 squared. So I'm just plugging this into the calculator. You don't have to simplify that exponent, but you can, but you're going to cut this in half twice. So you'd have 12.5 milligrams left after 12 hours. Now, part C there, the same thing. It says after 15, and this is not cut in half nicely. So 15, I'm going to cut it in half 2.5 times is really what we're doing there, but I'm just showing you don't have to simplify that. You don't have to reduce that fraction. You can do 50 times 0.5, and then all I would tell you to do here, if you cannot see your exponent, just put parentheses around it just to be safe. I would do 15 divided by 6 power. And a lot of the times these are not nice numbers. That first answer was, and it should tell you in the problem, hopefully, this says round to the nearest hundredth, so I'm going to go 2 decimal places here. So about 8.84 milligrams will be left. And then I just have one more at the bottom, and this is kind of what I was telling you guys about. It has to be in the same units here. So here's my very last question. It says I-123 is used in thyroid scans. It has a half-life of 13.2 hours. Write exponential decay function for a 360 milligram sample. So last one here. So this is going to be y equals, we have a 360 milligram sample, 0.5 anytime we're doing a half-life. X over the half-life is the exponent, 13.2 hours. Now, write the model, that's what we've got there. Use your model to determine the amount remaining after 3 days. Now, this is what I was telling you. So our half-life is in hours. So what we plug in for X has to also be in hours. So I do sometimes have to do maybe a little conversion on these. So 3 days, each day is 24 hours. So this would be 72 hours. So I got to make sure I pay attention to that. So when I answer the question of how much is going to be left, we want to make sure that our X value is in the same units, as our half-life. So when I plug that in, I need the 72 instead of 3, because 3 days is different than hours. So 72 hours out of 13.2 being the half-life. And to answer your question, again, for your exponent, just to be safe, I would put parentheses around it if you're not going to reduce it. So 72 divided by 13.2. If you are using a scientific calculator, do not try to use the fraction button with a decimal. The calculator will not like that, so use the division key. And how much would be left after 72 hours? We're going to round this. We'll go ahead and round it to the nearest hundredth. So 8.21 milligrams would be what we have left. Let me slide that so you can read my work. Okay, let me slide this to the side, and then I'm going to pull this up so we can actually see the other graph. So here's a bunch of, again, this is going to be a graph. Now, I know right away that we're going to work on graphs actually in a couple of days. So let me hold off on saying what I was about to say there. But let's try to pick some nice points. So I would always tell you, try to use that point if you've got a 0. Now I know it has a decimal here, but that's okay. We want to pick that. It's kind of a toss-up here. I'd probably use the -1, -2, but you can pick any 2 of those points. Do this process. I want to pick the X value that's bigger first, and honestly, if we've got 0, it doesn't matter because we're going to figure it out right away. So 0 equals AB to the, fail, sorry. Okay, sorry, let me start that over. I plugged in the X coordinate for the Y coordinate. So -0.5 equals AB to the 0. The other equation would be -2 equals AB to the -1. Now, this is extremely similar to the last question. This is just going to go because anything to the 0 power is 1. So I automatically know my A value right now is -1/2. So we're going to have to plug that into the other equation though. -2 equals -1/2 times B to the -1. Okay, now this would turn into that -0.5 staying on top. That's not being taken to that negative exponent, only that b is. And again, I would just turn this into a little proportion. -1/2 -2 times b. We're going to divide both sides by -2. Now if you want to think of this as a fraction, I'm doing -1/2 divided by -2. So if I keep that, change, and I'm going to flip that over, we'd have +2 divided by 2. So b there is actually just going to be 1.